So this is now the last topic under Chapter 9, and we are going to talk about measuring weight and temperature. So for this topic, we will be applying metric prefixes to the units of weight, convert units of weight within the metric system, use relationship between volume and weight within the metric system, dimensional analysis to change units of weight and to and from the metric system, and also understand the different temperature scales. So when we, in science, we have two different definitions for weight and mass, okay? So when we talk about weight, it is the measure of gravitational pull on an object. Mass, on the other hand, is the measure of quantity of matter in an object, which is determined by its molecular structure. So even though in science subjects, we have two different things when it comes to mass and weight, here in this particular topic, we will be using them interchangeably, okay? So when we're talking, if the word problem says the object has a mass of, it's also pertaining to weight, okay? Now, in the English system, these are the popular units of measurement for weight. We have ounces, pounds, and tons, okay? And these are their conversion factors. In the case of the metric system, as I have already explained before, gram is the basic unit for weight, and we still use those prefixes by powers of 10, okay? So let's take a look at converting 8.7 decigram and changing it to milligram. So since we are talking about changing within the metric system, then we are going to use our technique King Henry died, drinking chocolate milk, and grams is right here in the middle. So we are given 8.7 decigram. So it means that we have to start with D, and we need to go to milligram. So we start from here and we go 1, 2. So it means that from 8.7, we move our decimal point 2 places to the right, which means that we have a 0 here in this space, which means that 8.7 decigram is actually equal to 870 milligrams. Now we have 950 milligrams and we need to change it to grams, okay? So we start with milli, so that would be M, and to get to gram, we need to move to the left by 1, 2, 3 points to the left. So in this case, 950, the default decimal point is at the end. So from here, we need to move 3 decimal places, which means our 950 gram is actually equivalent to 0.95 or 950.950 grams, okay? Now, when it comes to volume and weight, okay, so you can also compare, there's also like equivalent values between volume, so for a solid figure, capacity, a liquid occupying a solid figure, and then the weight itself. So pretty much you can see that 1 cubic centimeters is the same as 1 milliliter, which is also equivalent to 1 gram. So this is what those 3 conversions are telling us. So in this word problem, we have an aquarium that holds 0.25 cubic meters. So this is our given. The question is, how much does the water weigh? All right. So in this case, we can look at changing, okay? So we have 2 options. When we talk about the weight, so we can change either to grams or to kilograms, okay? So what you can see here, between grams and kilograms, cubic meters could easily be converted to kilograms. So it's this last conversion. So we can use dimensional analysis, 0.25 cubic meters. We can use our conversion factor. Since we are given cubic meters here, we will put kilograms on the numerator. And the values are 1 for cubic meters and 1,000 for kilograms. We cancel our cubic meters. We multiply across. So we will have 0.25 times 1,000. So the unit now is in kilograms, which is going to be equal to 250 kilograms. So that's the weight of an aquarium that can hold 0.25 cubic meters of water. So here we have conversion between to and from English and metric system. So we have ounce and grams converted together, pounds and kilograms, and then ton with the normal ton, and then tone, okay, for the with the NE. Okay, so let's have, we are given 160 pounds, so that's LBS, all right, and we need to convert it to kilograms, so we're gonna be using the second conversion here. So we are given pounds and we need to convert to kilograms. That's on top. How many pounds? That's gonna be 1, and kilograms will take 0.45. We get rid of the pounds unit, and you can see that we will end up having a 160 times 0.45. The unit now is in kilograms, and all in all, this is going to be equal to 72 kilograms. There we have it. Okay, and then here in this example, we are given 300 grams, and we need to change it to ounces. So grams and ounces is going to be this first one. So our conversion factor would be grams at the bottom, ounces on the top. Grams will have 28, and then ounce is 1. We cancel grams. So now we will have 300 ounces divided by 28, and this is going to be about 10.7 ounces. All right. So that is how we can convert weight measurements both in English and metric system. Now let's talk about temperature. Okay. So typically we have two measurements, 2 units of measurements for temperature. Fahrenheit is the one being used here in the US, and the rest of the world is using Celsius. So for this two conversion, it's a good knowledge to know what temperature water freezes and boils. So in the case of Fahrenheit, it freezes at 32 Fahrenheit and boils at 212. Okay, and then water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. It's through these two, it's because of these two distinct characteristics that scientists were able to figure out a pattern on how they can convert one unit to the other. And so here is that formula. So if you are given a measurement in Celsius and you have to change it to Fahrenheit, what you need to do is multiply 9/5 to the measurement of Celsius. After that, you add 32, okay? If it's the other way around, you are solving for the Celsius version, you have to subtract 32 from Fahrenheit measurement and then multiply it to 5/9. So that's the formula to use to convert whichever temperature you are given. So let's have this example. So you have, you're in a European vacation, you're feeling a little bit feverish, the temperature reads 37 degrees Celsius. So are you sick or not? Should you panic? Okay, so what you are given is a measurement in Celsius. All right, so what do? We use the formula that says F is equal to, okay, because we need the Fahrenheit measurement. And how do we find the Celsius? What we do is we multiply 9/5 to the measurement in C, and then we add 32 in the end. So in this case, we will have 9/5 times 37. We add 32 to the measurement, and in this case, this is going to give us around 66.6. Adding 32, the Fahrenheit measurement is going to be at 98.6 degrees. So in this case, 98.6 is actually the normal body temperature in Fahrenheit, okay? Normal body temp, so no need to panic, all right? Now let's take a look. If we have Fahrenheit and we need to convert it to Celsius. So if the temperature is 77 Fahrenheit, this is now the given. How do we find the Celsius? So remember, with Celsius, what you need to do is you subtract 32 from the Fahrenheit measurement and then multiply that thing with 5/9. So in this case, we will have 77 minus 32. That difference we multiply with 5/9. And here, 77 minus 32, that's going to give us 45. And multiplying it with 5/9, we will get the measurement in Celsius to be 25 degrees. So that is a really nice temperature. And so you will have an idea that there's really big difference when it comes to Fahrenheit and Celsius. Now, if you are not aware, there is a third unit of measurement which most scientists are using, and that is what we call as the Kelvin temperature scale. So with Kelvin, all you need to do when converting Celsius to Kelvin is you simply add 273.15 to the Celsius measurement, okay? And then if you have a measurement in Kelvin, change it to Celsius, you just simply subtract 273.15. So visually, this is how the three different units of temperature compare to each other. So remember, this is when water freezes, okay? And then the value at which water boils is at these values. Absolute zero, so it's like the ultimate negative value, all right? So that would be if it is at 0 Kelvin, which means it's at negative 273.15 Celsius and almost around negative 500 at Fahrenheit, okay? So these are the three units at temperatures. Hopefully everything with discussed in chapter 9 will be very helpful, especially as you move forward. All right, thank you.